maximum accuracy on from a given set of minors on a given set of economically valuable time series forecasting tasks. Now, from there, we will be writing signals to a blockchain at inference time for trustless verification and monetize those signals. That's just sort of the large-scale goal, is to generate economically valuable edges over randomness in different time series in this method. Now, how we've been doing this so far is we've been training network-wide ensembles.
Expand the tanks.
Okay, let me explain. Yeah, we've been training network-wide ensembles on binary 1-hour forecasting, initially of Bitcoin, and now 9 different assets. Some saliences we average them out across the different assets. So right now weights are equal for each asset. So the way that the scoring works, just in a nutshell, is that if your embeddings, when randomized, degrade model performance by say you drop it from 60% accuracy to 55 when your embeddings are randomized, on a given task, you'd be getting about 50% of the rewards on that given task. That's how it looks right now. Now, so far, we've already seen that for binary forecasting, which is what we've been doing, has consistently outperformed simple buy and hold strategies. And we have a high confidence that this is not due to randomness or selection effects. And across most assets, the ensemble is better and has more stable performance than each individual minor. Now, let's continue. So, how we operate this on-chain and sort of the communications model is that miners upload a R2 bucket. They upload they commit that to the blockchain of BitTensor on that given subnet. So in that bucket at any given time are time-locked embeddings for 1 hour for this current time step. Those are decryptable after an hour. Validators fetch this once per minute. After 300 blocks, they decrypt this, and from those embeddings, they train logistic regression models, sort of squishing that down into one signal. Now, the reason why we train these logistic regression models is because initially, when designing the subnetwork, we assumed that miners would be using somewhat more, what I'd sort of call low-level features. So, for example, they could be feeding in different outputs of signal processing methods, on-chain data, and the like. However, that's simply not feasible to accommodate at scale due to the nature of how quickly we need to validate miners. So at this point, what we're incentivizing is actually just sort of raw predictions that should in and of themselves be accurate, not base features. Now we select the top K miners by area under curve on a validation set, and we train a network XGBoost tree on the out-of-sample logits from the selected miners' logistic regression models, optimizing for log loss on this classification task. So just to be clear, that's just simply up or down. It's a binary classification task as is. And as I said before, we permute each miner's selected validation logits, measure the area under curve drops, and we gain salience by that. We have a recency weighting, so the last 10, so it's with a 10-day half-life. So performance in the last 10 days determines 50% of rewards. This is somewhat newly implemented. Now, we have an incredibly small code base. We have only 5 core files. We have a ledger, which contains the logic for which holds the data log, the commit URL ingestion, the DRAM verification, the decryption, and the training data, which filters out periods of non-price movement, zeros, any times that anything is corrupted, etc. We have model.py, which defines the logistic regression models, as well as the XGBoost model and the salience, etc. We have validator, which is the central orchestrator. We have cycle, which simply downloads the cipher tags, and we have config. Now, these time locks are hotkey specific, so at the end of the embedding is the hotkey string, the SS58. If that is not appended to the end, the payload will be rejected. And here we go, this is just a little page information game as reward. And so how we train and evaluate each model And what we found to be the best in our testing, and which may or may not be the best way to evaluate the miner's contribution currently, is we take great steps to try to prevent data leakage. So for each miner, we fit the logistic on from 0 to selection fit end. We evaluate on selection eval start to selection eval end, and we like the top K miners on area under curve. Now, we do not actually evaluate the XGBoost model on the same logics which we used to select those miners, if that would create substantial data leakage from selection effects, obviously. And so this is just simply a little overview of what we do. And the end-to-end pipeline is we collect the payloads, the prices that are associated, we weight the horizon, we decrypt, we verify, and we set weights on chain. Now, this is some of our performance. Now, what you should really be looking at here, which is the most comprehensive, this is over the last 10 days. And so this is, of course, has what I'm really the most confident in is Bitcoin, because when I looked back to the last 20 days, this for Bitcoin generalized. For some of the other assets, it did not. For Ethereum, the performance improved a bit when we went on a longer horizon. For Ethereum, it dropped. For Great British Pound and the rest of the forexes, it stayed about the same, and on average we're looking at somewhere in the realm of 54% accuracy. Now, some of the incentives that this particular validation structure creates inherent to it is that relay mining, so that is the practice of looking at other miners' submissions and submitting them as one zone, is not economically profitable. It's not possible on the subnet. And to repeat your own line of signal. So if you had a subnetwork, for example, and how you were structuring it was you were simply looking at which miners had the best accuracy out of sample or in sample. What you'd effectively be incentivizing is for the best miner to take all of the UID slots to run their miner. This would be the most profitable behavior. So, and this is not necessarily aligned with what we'd like. Once a given set of signals, assuming that said signals are not perfectly correlated with one another, is on the network. Additional copies are not worth any more. Now, I will take a break here. Is this one on mine?
Yes.
So in the meantime, we're building a sub-sub network. This is on a testnet. It's actually being run live right now. And what we're trying to do here is we're trying to optimize the design of the network meta model and the savings calculation. Now, we've already moved simply from a multi-layer perceptron to an XGBoost model directly taking embeddings in to now this logistic regression to XGBoost. Now, how we've been doing that is we've been looking at how saliences are allocated, we've been looking for UIDs, and we've been just doing our own analyses with the data to make sure we're setting things fairly. And what we see is that we're in a decent state right now, but we could be much better, and that the moves that we've made already, such as moving from an MLP to an XGBoost to now how the system is today, have had tremendously positive effects. Now, how we're going to do this is we're going to generate synthetic data, which should effectively have returns. So the reason why we generate sort of a fake return series is that it'll have similar auto-correlation of the returns to real price data. This is sort of still in the works. We might even use real data, but I feel that generating synthetically has advantages. All code of miner submissions will be public, and the incentives will be based on improving the top submission at the given time. This is a bit of a page explaining the logic for that, or it'll effectively mimic what happens on the network to an extent. And with attrition, with new submissions spawn, let's keep going here. And so, really, one of the reasons for coming here, main reason, and the primary reason, is to point out the potential profitability for miners and for submitters on Numer AI to come work on this subnetwork. Now, we've paid right now somewhere in the realm of about $1 million out to different miners over the last 3 months. They've earned this money. We've only been running now for about 3 months. They've earned this, some of them have sold it and turned it into dollars. This is legitimate and real. And one who could say on Bitcoin USD submit embeddings with 60% accuracy, for example, could earn a tremendous amount somewhere in the realm, just simply on Bitcoin, of 20 to 30 grand per month within about 15 days of starting that miner. And you can verify that yourself with our evaluation script in our code base. Now, starting on the 25th, we're going to be notarizing the signals coming in from miners onto the Solana blockchain. So the logistic regression outputs of each miner and the meta model outputs encrypted to a fast layer 1. We're thinking Solana as we believe it's the best blockchain to do this on. And the reason for this is because right now the accuracy numbers requires that you trust the validators on BitTensor, including ourselves, to have not tampered with the data in any way, and that we're not taking into account any selection effects. So this will allow that to be done trustlessly, such as Sports Tensor has already done and shown off. And yes, so that's sort of the overview of what we're doing. We're iterating at an incredible rate, and we're going to be adding in volatility forecasting, and starting on about the 1st, we're going to be putting out a hourly auction of miner outputs. So winner takes all, the top bidder will receive the signals for the next hour for the challenge that they've bid on. That is sort of it. I'd like to see if there are any questions for the initial overview of what we're doing, just to flesh things out. I'm sure there are many. Yes, sir.
So I just want to know if I understand your selection mechanism correctly.
Yes.
Miners submit embeddings.
Yes.
And you train
Logistic regression models on those embeddings for each miner.
And then you pick the top K models.
Yes.
And concatenate the embeddings of them all and train an XGBoost model.
Yes.
Okay. And you also mentioned you went from an NLP to...
Yes, we initially just fed all miners embeddings into an MLP and did salience on that. And we stopped doing that for a very good reason, and that was that we were retraining each time. When we did that, it introduced a small amount of noise each time of performance sort of randomization, random changes, and this led to actually up to a majority of the rewards being given to miners who were submitting random embeddings and taking advantage of that randomness. Now, it's very possible that we could in the future find a way to implement a multi-layer perceptron without this issue, but it was a very lucky.
Could you be more specific about what sort of, an NLP could mean?
A multi-layer perceptron, like a neural network, like a feed forward.
I understand, but any specific
sure. We were using, I believe, 2 hidden layers of size 32 and 16.
Because, the thing is, what we call MLPs and LLMs are not exactly MLPs in the classical
No, of course, a large language model is...
every LLM also has an NLP layer.
Oh, I know within it, that's an MLP.
But we call it an NLP, but it's not an NLP. I mean, it's essentially what we call a Sweetle, right? There are multiple interactions. But a classical NLP is just,
It's just a feed forward network.
Two matrices, which is very
No,
different.
it's not just 2 matrices, there are also the activation functions.
Of course,
A
yes.
set of matrices and activation functions. Yes, it's... Yeah.
Okay, yeah, we can talk about this offline, but...
Anyway, any other questions?
Yeah, interesting is the correlate effect of Bitcoin liquidity on other assets. What do you think about the value of keeping the correlate effect in there? Because, Bitcoin goes up, everything goes up. Or would you scrub Bitcoin effect out of there for pure signal? Have you ever thought of that?
Well, I think that if there's a correlative effect that allows Bitcoin price increase to... So are you talking about sort of scaling rewards so that when, say, Bitcoin is increasing, other miners that are predicting increases at that same time, those increases are scaled less?
Well, if you think of like the Bitcoin pair, and then, always everyone asks, well, is it better off holding Bitcoin or not? So maybe it's good to, score the signal based upon the raw signal, scrubbing out the Bitcoin ball on other lesser assets because they're kind of correlated.
Yeah, and if we started forecasting those other assets, it would definitely make the math behind figuring out different civil attacks harder, right? Because there would not be a perfect, there would not be independence. So yeah, that is something to think about going forward. I think also something perhaps more important is later on having higher incentives for different increases. So say getting the model an accuracy of 55% is less valuable than getting it from 55 to 60%. And if you could get it to say 65% or 70%, that would be near unheard of on this task and far more valuable. It would be incredible and unheard of. So yes, that's something to think of. Okay, let's see here. Questions, anyone? Okay. So that is the overview of what we're doing so far. In the future, we're going to be expanding to different tasks. Oh, yes?
Yeah, wait, so how do you get involved? Is it, I don't see.
Okay, so this is a great question. So right now the process is that you fund an account, a BitTensor wallet with a small amount of tau. Right now I think that's about a tenth of a tau to register. It's less than that. You register a miner, you set up a Cloudflare R2 bucket. It has to be on Cloudflare right now. You download the repository, you look at sort of generated embeddings, you use that script or anything else to time lock the embeddings that you've generated for one or more assets, and you submit that to register a miner with that full key under a given hotkey associated with it. You use that to commit that public URL of that bucket to the chain, and you continually refresh the data that's in that chain. That's the whole process.
Sorry. Is there a tutorial on GitHub? So that process.
Well, there's a generate embeddings.py and there's an evaluate embeddings.py that lets you sort of estimate historical. Like if you have a deterministic script that can take in a timestamp as a block and output embeddings for that timestamp, you can see the historical performance, and you can have a script that sort of shows how. And I think that there's a minor guide which just goes over what I just said and sort of what I put right here in the mining what to do in a little bit more detail. But no, there's not any tremendous resources for how to mine.
That's right. Thanks.
But it is quite a, yes?
First of all, congratulations, you will stay young, Dave, Matt, and also Lego.
Thank you.
And so I wonder, you get all of that alone, or you work with a team? And another question is, what is MANTIS? Is also a token?
Well, it's subnet 123 on BitTensor, so it is a token, and we plan to, with any revenue that is generated from the outputs of the network, buy back and burn that token to generate value for the token. And while the development is primarily done by myself, I do consult many other people, and I do work with my family in general. So it's not like I'm doing this alone in like a basement somewhere. No, yeah.
Not true.
Yeah, we need.
One-man army.
When you mean the token, you're talking about the alpha.
Yeah, I'm talking about the alpha.
The alpha subnet token.
Yeah, and there's no plans to launch any token outside of BitTensor at any point. Yes.
Do you have any plan to monetize your vision engine?
Yes, precisely. On the first, we're going to start start auctioning out the meta model outputs. We expect to have initially a very small amount of interest at first. And if we can demonstrate consistent long-term returns that exceed the market, that's inherently valuable. We may purchase those returns ourselves with a set budget, like a set maximum amount, and say, use that to mine any other subnets that may find that useful, or simply trade on them with personal funds. Yeah.
So your plan is actually just solely based on it.
What do you mean? Well, no. The information of the signals is like sort of inherently valuable, so to speak.
Okay, yeah, I mean, the plan of operation, you try to sell.
Yeah, to sell that information or to utilize that information in a way that effectively sells it. Because that information sort of has almost a set value because there's a maximum amount of money on which it can be traded without running into liquidity issues and getting rid of the edge. So there's some range of a set value of what that information is worth. That's relatively tight. It's not like say LLM inference where it can really depend on demand and
All right. Thank you.